Hi, my name is Bahadur Akhmedov. In this video lecture, we are going to discuss about derivatives of the power functions. So this is going to be our first video in a series of the video lectures where we are going to try to derive the formulas for the derivatives of a standard functions. So let's say you're given some function, the power function x in the power of n. Its derivative is going to be found in this way. So essentially, this power n is going to go down and it's going to be written n times the x, and its power is going to be decreased by 1, so it's going to be n minus 1. And it works for all of these functions like this. So what we're going to do in this lecture, we are going to try to see a couple of examples how to use this formula, and then we're going to also try to prove this. So it's one of the important tools which we are going to discuss and learn throughout these lectures, because we are going to try to get the formulas of the derivatives of the standard functions for in the same way. We're going to try to prove this in the same way for all of the other functions as well. So let's try to do some examples. So I would like to start with this simple example like y is equal to x in the square. Then the derivative of the y is going to be equal to this 2, basically, is falling down to here. It's going to be 2 times the x, and the power is going to be decreased by 1. It's going to be 2 times the x simply. So, well, when you are having the integer values on the power of the x, it's more or less easy, right? So, for example, if you're given y is equal to the x in the power of 4, it's also easy that 4 basically is falling down to here. It's going to be 4 times the x in the power of 4 minus 1, which is 4x cubed. So sometimes we need to deal with this kind of functions, square root of x. So at the same time, we know that we can rewrite the radicals, so the square root of x, as the x in the power of 1 over 2. And if you would like to find the derivative of this function, you have to do the same technique. So essentially, the power is going to fall down. So this is going to be 1 over 2, x in the power of 1 over 2 minus 1. So now let's try to simplify the power of the x. It's going to be 1 over 2 times the x in the power of 1 over 2 minus 1. It's going to be minus 1 over 2. So if you remember, we can write down these numbers. So this power, the negative power, is a reciprocal. So it's going to be x in the power of 1 over 2. So we are essentially using this formula. A in the power of minus n can be written as a 1 divided as a in the power of n. Okay? Then x in the power of 1 over 2 is nothing else as the square root of x. So it's going to be 2 square root of x. So that's why the derivative of the square root of x is going to be 1 over 2 square root of x. So this is how we need to deal with the power functions where the powers are the rational numbers. So the ratios between the two integers as well. So now let's try to prove this formula. So why exactly the derivative of the power function is going to be found using this formula. Oops. It's basically one of the most important formulas for the derivatives, by the way. Okay, so if you remember the definition of the derivative, so how we find the derivatives is definition of the derivative using the limits was f prime of x, or at some point x0, is equal to the limit of f of x plus delta x minus f of x divided to the delta x, where this delta x goes to the 0. So sometimes we basically denote this delta x with another letter. So let's try to denote this with the h. So I'm going to write this down a little differently so that it's going to be easier for us in our calculations. So x plus h minus f of x divided to the h, where this h goes to the 0. Then what I have to do is I need to just plug in here all of the things, all of my functions. So let's say your function is given f of x is equal to the x in the power of n. Then just substitute this function to here and to here. Okay, so let's find this. So I need to find the limit of f of x plus h minus f of x divided to the h. So this is going to be the limit of, so x plus h in the power of n, right? So because if you plug in this function to here, you're going to get x plus h in the power of n minus x in the power of n divided to the h, and we have to find its limit when h goes to the 0. Well, what I have to do first of all is we need to expand this this product. So the x plus h in the power of n, we need to open up the brackets. And as you remember, we've learned about the binomial formula, which allows us to do this. So it basically tells us that, hey, so this is going to be equal to the sum of the k from 0 to the n, c, n, and k, h in the power of k, let's say. So let me start from the 0. Okay, so h, k in the power, x in the power of k, right, times the h in the power of n minus k. Okay, so let's write down a couple of first terms of this. So let's start with the x in the power of n minus k and h in the power of k. Okay, so it will be easier for us to do the simplifications. So I'm going to try to write down a couple of first terms. When k is equal to the 0, so let's substitute k to be equal to the 0 for all of the appearances of the k here. So it's going to be c n 0 x in the power of n, h in the power of 0, right? Plus cn1, x in the power of n minus 1, right? Times the h in the power of 1, plus cn2, x in the power of n minus 2, h in the power of 2, and so on. Okay, so I don't need other terms. So k is equal to the 1, k is equal to the 2. Okay, for all of the terms, it's going to be like so we are going to have the h cubed, h in the power of 4, until they will reach the h in the power of n. So the last term is going to be simply h in the power of n. By the way, the first term here is simply x in the power of n, right? Because the c and 1 is simply equal to the 1. If you remember the formula for the c, it was like c and k. It's like n factorials divided to the k factorials times the n minus k factorials. So that's why if you calculate c and 0, it's going to be n factorials divided to the 0 factorials times the z n minus 0 factorials, which is simply n factorials divided to the n factorial, which is equal to the 1. Okay, and this is also equal to the 1, so that's why the first term is x in the power of n, and the last term is h in the power of n. Okay, so you see, so we're starting from the x in the power of n, and we're finishing h in the power of n, and all the terms between are going to have the combinations of the x and h. Okay, so let's try to evaluate this one here. So if you evaluate this, it's going to be equal to the n. So we can even calculate this as cn 1, it's going to be n factorials divided to the 1 factorials times the n minus 1 factorials, right? So what is the n minus 1, n factorials divided to the n minus 1? It's going to be like a 1 times the 2 times the n minus 1 times the n. So this is the definition of the n factorials. And the definition of the n minus 1 factorials is going to be 1 times the 2 until n minus 1. Okay, so all of these terms are going to cancel. These terms and these terms are going to be canceled. And what you have is simply n. Okay, so the second term here is going to be equal to the n times the x in the power of n minus 1 times the h. Okay, so the third term here, so let me calculate the third term. So in order to do this, we need to calculate s the cn2. It's going to be n factorials divided to the 2 factorials divided to the n minus 2 factorials. So it's going to be actually n times the n minus 1 divided to the 2. Okay, so the third term here is going to be n times the n minus 1 divided to the 2, x in the power of n minus 2, h in the power of 2, and so on. Okay, so here are all of these terms. So if you just expand this, so this is going to be the first term. So this is what we have to expand. This is going to be the first term. This is going to be the second term. This is going to be the third term. And this is going to be the last term, nth term. Okay, so let me substitute all of these things to here. So this is going to be, so the limit of x plus h in the square minus x in the power of n not in the square, in the power of n, right, divided to the h. So I'm going to substitute all the first terms, all the first three terms. So x in the power, x plus h in the power of n. It was x in the power of n, right? Plus, it was, so the second term was here. This is the second term, right? So this is n times to the x in the power of n minus 1 times to the h. Plus, the third term was n times the n minus 1 divided to the 2, x in the power of n minus 2 times the h in the square, and so on, plus h in the power of n minus this term, right? So this is so all of these terms here, all of this n plus 1 terms basically, are going to be just the expansion of this term. So I have to subtract x in the power of n, and then I have to divide these things to the h, and I have to find the limit when h goes to the 0. Okay, so you see, so if you subtract this term and this term is going to be cancelled, and I'm going to divide all of these terms to the h, because all of the other terms are going to have the h with themselves. So it's going to be the limit of h goes to the 0. It's going to be, if I divide the first term to the h, it's going to be simply n times the x in the power of n minus 1. Plus, if I divide the second term to the h, it's going to be n times the n minus 1 divided to the 2 times the x in the power of n minus 2 times the h, right? H squared over h, it's going to be h plus and so on. All the other terms are going to have the h in some sense. And the last term is going to be h in the power of n minus 1, okay? Where h goes to the 0, this term is going to the 0, okay, because I have the h here, and all the other terms are also going to the 0. And you see, so this term doesn't have the h at all, so this is simply going out from the limit. It's going to be equal to the n times the x in the power of n minus 1. So this is actually the value of the limit, x in the power of n minus 1, which is the derivative. So we just found that the limit of f of x plus delta x minus f of x divided to the delta x, or let me put the h, right? H and h, when h goes to the 0, is equal to the n times the x in the power of n minus 1, which is the derivative of the function. So that's why if your function is given as the x in the power of n, then the derivative of this function is going to be equal to the n times the x in the power of n minus 1. So this is the proof of this formula, and we've seen a couple of examples for this formula. So I hope that this was helpful for you.